Hey class, Miss Jones here. Today we're going to be talking about a type of transformation called a dilation. This one is special because it is the only one of the transformations that changes the actual size of the shape. Instead of being congruent, all of the dilations are similar, which means that they are going to be proportionate to each other. Okay, so let's explore this concept really quick with a fictional Harold who is going to be telling us a story. Here we go. Harold and his friends went to a wizard camp where they took a class on spells and potions. Harold drank 4 potions in a row that caused him to grow or shrink based on the potion's scale factor. Okay, scale factor is going to be an important vocabulary word. Just highlighting it there. Note the effect that each potion had by writing grow or shrink under each table. Then answer the questions. Okay, so we have a fictitious wizard who is taking potions for some reason. Okay, so let's look at potion number 1. Looks like Harold started out 60 inches tall. Okay, that's about 5 feet. After a scale factor of a half, now Harold is 30 inches tall. Well, obviously, this one is him getting smaller, so I'm going to put shrink right here because he got smaller. Potion number 2. We start off at 30 inches tall. The scale factor was 2.5, and now Harold is 75 inches tall. 75 is more than 30, so I can say that he is growing. Okay, so what I want us to do is I want us to take a look at the different scale factors. Okay, when we had a scale factor of a half, we were getting smaller. When we had a scale factor of 2.5, we got bigger. Okay, so let's keep going. On potion number 3, we had a scale factor of 0.2, and we went from 75 inches to 15 inches. Okay, that is obviously smaller, so I'm going to put a shrink right here. And our last potion, potion number 4, we started off at 15 inches. Scale factor was 8/3, and now he is 40 inches tall. Okay, so obviously 40 is bigger than 15, so we are growing. Now, as we look at these scale factors, we're going to be answering some questions. The first one asks, which scale factors made Harold grow? Okay, we had this one, that was 2.5. We also had this one, which was 8/3. Okay, so which scale factors made Harold shrink? Well, this one that was a half, and this one at 0.2. Okay, notice we're using fractions and decimals. All right, what do we notice about the differences between the scale factors that are going to make Harold grow and the scale factors that are going to make Harold shrink? What do we notice? Predict what would happen if someone drank a potion with a scale factor of 1. Okay, these are some interesting questions that I want us to be thinking about as we look at our next few questions. Okay, so we're going to be skipping down and getting some definitions, okay? A scale factor, these numbers, you might have been wondering, well, what the heck are these and what are they doing mathematically? Okay, so a scale factor is a ratio. Remember that ratios often look like fractions and can be converted to decimals of corresponding sides of a figure. Okay, so if you have 2 shapes, just like we had a shape that we started off with, have a triangle, and then we dilated that shape so that it was now bigger. Okay, the ratio of the new shape to the original shape, that would be called our scale factor. Okay, so to show you an example of this, I'm going to use this space down here, and we're going to have a triangle, and we are going to say that this side right here is 7 inches, and this side is 5 inches. Now, if I were to do a dilation and get a similar but bigger figure, okay, the scale factor, we're going to think of it in a few different ways. First, let's talk about this ratio we were talking about earlier. If this is my original shape or my pre-image, and this is my new shape or my image, the ratio, let's just take some sides that match up, would be 10 to 5, which can reduce to 2. My scale factor is 2. Now what I want you to notice here is that this shape is 2 times bigger than this shape. That's what that scale factor of 2 means. You can find the scale factor by doing this ratio, but the scale factor means this is twice as big as this, and you can see that that is true. Now, there's something interesting that happens because when you're doing a dilation, the shape can get bigger, but it can also get smaller. So if the scale factor is bigger than 1, 2, 3, 4, 1.5, then you will be enlarging the figure. You are going to be making it bigger. If the scale factor is less than 1, meaning 1/2, 0.3, any of those smaller than 1 numbers, then you will be reducing the size of your figure. Okay, that's very, very important. So hopefully you're getting this highlighted. Now, when you're looking at a dilation is a transformation that either makes something bigger or smaller, reduces or enlarges the figure. To dilate a figure, all you have to do is multiply by the scale factor. Okay, so we're going to be doing a lot of multiplication. Now, because we know we're going to deal with some fractions and some decimals, this is a friendly reminder that if you're feeling a little rusty on that, your calculator can do it for you. All right, so let's go ahead and take a look at our first couple of problems and see what a dilation looks like. We have our pre-image right here. Okay, this is the original, and it is 15 inches by 35 inches. And I'm being asked to dilate each of these figures, each rectangle, by the scale factor. This means I have to take 15 times 2/5. So I'd say 15 times 2/5, put that in my calculator, and I get 6. Now we're going to do the same thing to the other side. Okay, so we know what this side will be. Now we need to look at this side. Well, 35 times the scale factor of 2/5 is 14. So what that means is my new rectangle, if I were to draw it in right here, would be 6 inches on the side and 14 inches long. So as you can see, multiplying by a fraction made this image smaller. It is by a scale factor of 2/5. Okay, let's try another one. This time we have a rectangle, and the scale factor is 3.5. So we're going to be using the same process. We're just going to multiply this side by 3.5, and we're going to multiply this side by 3.5. And then I will get my new shape. And I know I'm not drawing to scale. As long as I label it correctly, I think we'll be okay. So I'm going to go ahead and multiply. 22 times 3.5 is 77. So this side is 77 because these two sides, they kind of match up, okay? Next, we need to do the top part. I need to do 10 times 3.5, which is 35. And my new shape got bigger. Okay, I think you get the idea. I want you to try number 3 on your own and come back and we'll check your answers together. Ready? Pause the video. Go. Okay, you should have gotten 9 times 5/3 is 15. 30 times 5/3 equals 50. So my new shape is 15 by 50. But wait a minute, I thought when we multiplied by fractions, the shape was supposed to get smaller. This shape got bigger. I started off 30, now it's 50. So what gives? Oh, it's because the fraction 5/3 is actually an improper fraction, which is the same thing as 1 and 2/3. This number, even though it's a fraction, is bigger than 1. Okay. So now that we've got this down, let's take a look at number 4. We're kind of doing it backwards. The shapes have already been dilated. You see we have triangle HGI, and then it's been dilated to HGI prime, and our job is to figure out what was the scale factor. All right, so this is very, very simple. And I want you to think back to when we were talking about this formula right here. In order to find scale factor, it's just a ratio or a fraction. The new shape divided by the original. Okay, so let's take a look. I'm just going to choose two sides that match up or are corresponding to each other. Okay, these two sides match up. They're both in the same spot. It's HG and it's H prime G prime. Same thing. And what we're going to do is we're going to take the new shape, which is going to be the number that goes in the numerator. Okay, we want new divided by old. The new number is 10, and the old number was 8. So my scale factor is 10/8. Okay, that's easy enough. Let's try another one. Okay, this time we have rectangle XYWZ. Okay, again, we want the new shape divided by the old shape. So I'm going to choose this side. Okay, side XY and XY prime. The new is 12. And the original shape is 18. So my scale factor is 12/18. Voila! That's how easy it is. Now, if we wanted to, we could reduce this fraction. As always, we can, but technically... Okay, and for the interest of time, we are going to skip number 7 and let you get straight to the practice so that you can get that done within the class period. Remember to check your work, and have a great day.